Hi friend, how are you? I hope you are doing well. Dear friends, today I have come here to discuss about phase velocity and group velocity. As we know that phase velocity and group velocity are very crucial in the study of quantum mechanics. So I have decided to discuss about phase velocity and group velocity in this video. In quantum mechanics, phase velocity and group velocity are crucial concepts for understanding the behavior of wave-like particles. Dear friends, in this video, we will discuss the major 4 points about phase velocity and group velocity. The first is its definition, and second point is significance, third is its application, and the fourth is mathematical expression. First of all, we will discuss about the definition. What is the definition of phase velocity? Phase velocity is the speed at which a single frequency component of a wave propagates through space. And what is its significance? Not always physically meaning. In some cases, phase velocity can exceed the speed of light, which does not necessarily violate relativity. This is because phase velocity does not represent actual transport of energy or information, and it is useful in certain contexts. It can be useful for analyzing the propagation of individual waves within a medium. Similarly, for group velocity, the definition of group velocity is that the speed at which the overall shape or envelope of a wave packet, that is a localized group of waves with slightly different frequency, travels, and its significance, physically meaningful velocity. When a wave packet is traveling, group velocity represents the speed at which energy and information are actually transported, and it is crucial for particle behavior. In quantum mechanics, particles are often described by wave packets. Group velocity determines how the particles' position and momentum evolve over time, and it has a very crucial application in particle wave duality. The concept of group velocity is essential for understanding the wave particle duality of matter. It helps to reconcile the wave like behavior of particles described by wave functions with their particles like properties such as momentum and position. Now friends, we will discuss about mathematical expression. As we have already discussed that when a single wave of a definite wavelength travels in a medium or in a space, the rate of propagation of phase of the wave in the medium or space is called phase velocity or the wave velocity. Wave velocity means phase velocity. If, however, a number of waves of different wavelengths are moving with different velocities in a medium or a space, then the observed velocity is the velocity of the wave packet or wave group formed by the waves. The group velocity of a wave group or wave packet is the velocity with which the overall envelope shape of the wave's amplitude, known as modulation or envelope of the wave group, propagates through the medium or space. The group velocity is less than the wave velocities. This is the pictures representing wave group velocity and phase velocity. Okay, the envelope is representing wave packet and its velocity is representing group velocity, and individual wave is representing the velocity of individual wave is representing phase velocity. In the above figure, two simple harmonic waves of slightly different wavelengths and wave velocity are shown. The two waves give rise to a wave group. The maximum amplitude of the group wave moves with a velocity slightly smaller than that of individual waves. Thus, the energy follows with the group velocity, and the observed velocity is in fact the group velocity. Now we will derive mathematical expression. Let us consider a wave group formed by following two waves of same amplitude A but slightly different frequencies and wavelengths. Amplitude is same but frequency and wavelengths are slightly different. The first velocity, first wave y1 is equal to A sin omega t minus kx. Okay, here A is amplitude and omega is what? Omega is angular velocity, and k is wave constant, propagation constant. It is called as propagation constant. And now consider another wave y2 is equal to A sin big bracket enclosed by a smaller bracket omega plus d omega. Because it is slightly different frequency, so we have added here dw into t minus here for propagation constant also we have added a slight magnitude, that is dk. So expression as you are seeing in the picture, where k is equal to what? 2 pi by lambda is called the propagation constant. Now the resultant displacement is given by, as you know, what is resultant displacement? Y1 plus Y2, and we will put the value of Y1 and Y2. Okay, so we are seeing this in the picture. Now, how will we add this? Since sine A plus sine B is equal to what? 2 sine half bracket A plus B bracket closed cos half bracket A minus B bracket closed. This is the formula of sine A plus sine B, and we will use this formula in this equation. So, using this formula, y is equal to what? 2a, okay, and sine big bracket enclosed by a smaller bracket omega plus d omega by 2 smaller bracket closed t minus a smaller bracket k plus dk by 2 a smaller bracket closed x. X is what? X is the axis in which the wave is traveling, and cos big bracket d omega t, okay, minus dkx and enclosed by bracket by 2. This is mathematical expression you can see in the picture, okay. As dw and dk are very small, so omega plus d omega by 2 is equal to omega, because dw is very small, so it is equivalent to omega. And similarly, k plus dk by 2 is equal to k. Therefore, we can put this in this equation, then we will get y is equal to 2a sine omega t minus kx cos big bracket d omega by 2 t minus dk by 2x, and solving this, y is equal to 2a cos dw by 2 t minus dk by 2x into sine omega t minus kx. The sine factor here represents wave of the same frequency omega and same wave propagation constant k as one of the component waves having a wave velocity. So, here nu is equal to omega by k. The cosine factor represents a slowly varying function. Here, cosine factor is representing what? Slowly varying function, okay, of both x and t. Okay, it is dependent on x and t both, and modulates the amplitude of the resultant wave. Cosine factor also modulates the amplitude of the resultant wave. It represents the wave group whose group velocity as seen from its form is u is equal to d omega by dk. Okay, this is the expression for the group velocity. Here u is equal to d omega by dk, the rate of change of omega with respect to propagation constant is group velocity. The relation between group velocity u and wave velocity v since k is equal to 2 pi by lambda, so u is equal to d omega by, here we will put the value of k 2 pi by lambda, and so u is equal to minus lambda square by 2 pi into d omega by d lambda. Okay. Now since v is equal to, here v is what? V is representing phase velocity. Okay. Since v is equal to omega by k or omega is equal to vk, and so it will be equal to 2 pi v by lambda, and we will put this value. Okay, and we will get u is equal to minus lambda square by 2 pi d by d lambda bracket. Now we have put the value of omega 2 pi v by lambda. Okay, so u is equal to minus lambda square small bracket minus v by lambda square, it is differentiation, plus 1 by lambda dv by d lambda. Here we have differentiated. Okay, so we have get this value, and now finally what we have got? We have got u is equal to v minus lambda dv by d lambda. From the above equation, group velocity is smaller than wave velocity. What this equation is showing? Group velocity is smaller than wave velocity. Why? Because group velocity is equal to wave velocity minus there is a component lambda dv by dt. Okay, so it is lesser than wave velocity. In the absence of dispersion in the medium, dv by d lambda is equal to 0. Here dv by d lambda is representing what? It is representing a rate of change of phase velocity with wavelength. Okay, and if there is no dispersion, then there is no change in velocity. So dv by d lambda is equal to 0. Thus we have u is equal to v. When there is no dispersion in the medium, then u is equal to group velocity is equal to phase velocity. But when there is dispersion of velocity with respect to lambda, that is wavelength, okay, then u will be smaller than v, that is group velocity will be smaller than phase velocity. So this was the expression of group velocity and phase velocity. I hope you have understood this expression. If you find any difficulties, then repeat this video. Okay, repeat the expression part of the video. Watch this video two or more, 2 times, 3 times. You will understand easily. So this was the concept of group velocity. So what was learning in this video? That group velocity is either smaller or equal to phase velocity. Group velocity cannot be greater than wave velocity. In many cases, we see wave velocity is greater than the velocity of light. Okay, but there, since we have already discussed that since wave velocity does not represent the transportation of energy. Okay, so it does not violate relativity, but group velocity represent the transportation of energy. So group velocity will never be greater than the velocity of light. From this expression, what we have understood here, that group velocity is smaller than phase velocity. What does that imply? That implies that wave packet travels slower than phase velocity, that is individual wave. It means wave packet lag behind the individual wave. In the picture now I will try to visualize this by some motion picture. In this first picture, it is showing that propagation of a wave packet demonstrating a phase velocity greater than group velocity, and similarly this is second picture, which is showing phase velocity going opposite to group velocity. Okay, the group velocity is in positive direction, that is in right hand direction, and phase velocity is showing in negative direction, that is left hand side direction. So in this picture we are seeing that envelope of the wave packet is traveling slower, okay, then the phase velocity. This is a demonstration of visualization of the concept of group velocity and phase velocity. Thank you, dear friends. I hope you have understood. If you find this video useful, then please like this video and subscribe this video so that you will get the notification of the next video. Thank you.